So today I started on making the 2-point probe project. Sorry, let's take these off. And so as in the YouTube video, I have, instead of builder's block, because I don't have any builder's block, but we have a lot of wood in the basement. My husband fortunately has a lot of tools and hand tools, and we have a lot of spare wood, so I cut this block into approximately 2.5 inches square. And so now I also, fortunately, just very luckily from my high school, happen to have a copper bar. It's pretty thin. I've got to measure the thickness of this. I probably have some kind of caliper somewhere. But anyway, I cut this in half with tin snips, so the edges are kind of ragged, like this. But so I had to kind of eyeball, because what I want is to make sure that I have at least one edge that's the same length as the other edge. And so these, when I put them like this, the cut edge is up here, but on this side, these are approximately 2.5 inches. They're actually a tiny bit shy according to the ruler. So my next job is to attach the copper strips to the sides of the block, and they'll have to stick out a tiny bit so that they can make contact with whatever sheet that I'm trying to measure the resistance of. So I'll attach them this way, and probably, I don't know, I got to figure out the fastening method. I was thinking glue, but maybe it'd be better to use some kind of screws to screw this onto the wood, and then I'll have to design some kind of way to hold the multimeter probe tips onto the copper sheet with good contact. Also have to figure out whether the multimeter is actually going to be able to pick up a resistance that's so small. So that's the next step. So I wanted to see how thick this copper sheet was so that I could at least have some idea of the amount of thickness it was going to add to my wood block here. Because remember, for the square resistance, we want the copper sheet to be exactly the same length as distance apart. Otherwise, we don't have a square anymore, and we're going to introduce some inaccuracy in our sheet resistance. So using this old-fangled device called a micrometer, and it has divisions of thousandths of an inch. And so measuring that, I get about 20 thousandths of an inch, which comes out to about 0.51 millimeters. So now I know that I'll be adding about half of a millimeter to, well, I guess about a millimeter to the side, to the width of the wood. All right, so I've now clamped my piece of copper onto the piece of wood, and I'm going to drill a hole so that I can attach it to my block of wood. Drill, and I'll just drill 2 holes kind of near the middle, because it shouldn't really matter too much about where I put these holes. They're just for attaching. So there's one. Just flip this over. There's the second hole. So now I have 2 holes. Just have to repeat this with the other piece. I'm now testing the 2-point resistance probe with instead of using the household Radio Shack probe, which has very oxidized tips, we're now using the multimeter that was borrowed from Jim from the lab. I'm going to test various things using the probe, and we'll record different resistances. I have the list of items that we're going to test here. The first thing we're going to test is the aluminum foil, the dull side. I read online that there is actually a polymer coating on one of the sides of aluminum foil, and that's why it looks dull rather than shiny. Okay, so I have my aluminum foil, I have my 2-point square resistance probe. I've sanded the edges of the copper sheet just to make sure that I got rid of any oxidation that's built up, since I haven't used this for a couple weeks now. It's been sitting around. So that will go contact onto the aluminum foil this way, and then I'll attach 2 alligator clips to the contacts here. So we have the 2 contacts, one there for that side, and then also we'll attach a clip over here on this side. And then here's my multimeter. Let's see if I can get this set up so that you can see the reading on it. All right, so let's put this on. So basically we're going to be measuring the resistance across between this square area of the probe. So I'm going to connect the alligator clips to the multimeter. Hold these apart. Okay, so we're going to set this on ohms here. And we're going to be measuring pretty low resistances. And so it's possible that we may not even measure any resistance in the case of aluminum foil. Let's see if we can get... Okay, so I'm going to press down and see if maybe we get anything. And on this side, it looks like we are not getting any reading here. Maybe the one may mean that it's too low to be detected. So that's pretty much the same thing that we got with the household probe as well. The resistance was just too low. All right, so let me make a note of that on my sheet here. Okay, so next let's turn it over. Most likely if the dull side of the aluminum foil didn't give us any reading, probably this side will also not give us any reading. Place it on here. Again, the reading does not seem to be changing at all. Oh. Actually, now we are getting something. Make sure that we're getting really good contact. I'm going to press down on this, and we'll wait until we get a steady reading. Seems like 2.3 is probably about that, so let me write that down. That was the shiny side. Let's go back to the dull side again. The thickness of it is definitely greater. I'm not sure if just the resistance is so high that we can't measure any sort of current flow at all. Okay, so before we go on to the liquids, I figured maybe it's time to just make sure that the multimeter is working correctly. Set it back to 200 ohms setting. And I have a box of resistors, so take one out. Here we have some 100 ohm resistors that should be easily detectable using the multimeter. Just make sure that everything is working correctly, so that it's not the meter's fault. So putting that across here, and we're getting a pretty steady measurement of 102.6. It is definitely fluctuating a little bit. Try to get these. These are as good contact as possible. Okay, so getting pretty good steady reading, a little fluctuation. Something labeled a 0 ohm here. I'm not sure exactly how something could be 0 ohms, but for this I'm going to put the alligator clips back on. We're getting 3.2. So if this is 0 ohms and it's reading 3.6 or 3. It's the meter's definitely a little higher than it should be. Okay, let's test one more resistor. 0 ohm resistor back. We also have 10 ohms here. Let's see what we get for 10 ohms. Just took a little bit. So 13.1, 13.0. So the meter definitely reads a little bit higher than it should, given that these resistors should be pretty close to. These are all plus and minus 1%. So the meter is definitely reading a little bit higher than it should be. Depth of tap water. And that depth is about half of a centimeter or 5 millimeters. Let me get the water spread out evenly. It's a little hard to tell from here. The camera's not going to be able to pick this up. It's a little hard to tell because of the meniscus, and the water's kind of clinging to the side. Maybe a little bit lower than 5. Tiny bit more water here. All right, so pretty close to 5 milliliters of water. And we're going to try for the 5 millimeters again. That's good. All right, put the probes in, and we're getting something now. We thought maybe we'll move the meter over here. Yep. Okay. Oh, we did have a measurement for a while. Yep. It's kind of on the, it's possible it's just on the, there we go.